Okay, let's go over the Solubility 1 quiz. It was take home. I would like you to all take that out, trade and grade right now. Once you're done with that, we'll pick it up after this. So we'll pause right now. Okay, hopefully you have somebody else's worksheet quiz. Let's go. First question. First question says, which diagram best illustrates the hydration of sodium ions in an aqueous solution? The important thing here to remember is that the water molecule, this right here, all right, this, you have to remember, is a polar molecule. And as a polar molecule, you got to consider that it's polar because one end is negative, one end is positive. This end up here, this end up here, this is your negative end up by the oxygen. This end down here, this end is your positive end of the molecule. Because of that, opposites attract. We need to remember that the sodium ion is positively charged, so therefore the water molecule will have its oxygen end pointing towards the sodium ions. And so that's why answer number two, that's your best answer, with the negative oxygen pointing towards the sodium ions. Okay, question number 2 says, according to table F, so make sure you have table F out. Which of these salts is least soluble in water? The least soluble one is going to be one that is on the unsoluble side, the insoluble. Well, right away you see you have lithium, you have rubidium. Those are group 1 metals. You know those are always soluble. There's no exceptions right here. Right? So you can cross those off. They're soluble. Now we come down to the chlorides because you have chlorides, right? So you're looking at these, and so right there it says the lead chloride is the one that is insoluble, so this is your answer. Lead chloride is the least soluble of the bunch. Next question is asking which compound is the most polar. You need to remember your electronegativity differences, but more importantly, you need to remember your electronegative trends. The most electronegative element is this one right here, fluorine. That's the most electronegative. All of these are being compared to hydrogen, 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 hydrogen. All right? So as you further away you get from fluorine, the less electronegative it is. You want the greatest electronegativity difference to being the most polar. All right? Most polar means greatest electronegativity difference. So the greatest electronegativity difference would be the one that is closest. So oxygen and fluorine, they're right here. Okay? Then you look at your choices. The choices are sulfur, selenium, tellurium. They get less electronegative as you go down. So the most polar compound that you're having here is the greatest electronegativity difference. That is water. And you should know that already anyway. In this one, number 4, this again has to do with the water molecule. Remember, the water molecule is a molecule that is polar. And so you have a polar molecule that has a negative end and it has a positive end. There's your negative end. Here's your positive end. Opposites attract. The sodium ion is positive. The sodium ion is positive. The oxygen end is negative. So this is a negative. That's a positive. We have a negative. That's a positive. So that's your choice. Number 1 is the correct answer. Opposites attract because water molecule is polar. Number 5, the attraction between water molecules and the sodium ion or the chloride ion occur because water molecules are, again, water molecules are polar. I just said the water molecules are polar. You need to remember that. Water molecule is a polar molecule. If there's nothing else you remember in chemistry this year, remember that water molecules are polar. Number 6 talks about which salt is least soluble. That means that's code for insoluble. Well, we're looking at a couple different choices here. We're looking at either carbonates or we're looking at chlorides, carbonates or chlorides. Here's your carbonates right there, okay? Over here are your chlorides, chlorides right here. Now, most of the chlorides are soluble. Halides, chlorides, they're soluble except with these conditions: silver, lead 2, or mercury. Is that one of our choices? No. So that means that these guys are both soluble. So those are not your choices. We're looking for something that is least soluble. Those guys are soluble. Carbonates, however, they are insoluble. Right here, a carbonate, they form insoluble compounds, except with group 1s and ammonium. Well, do we have a group 1 or ammonium? Yes. Right here is a group 1. Group 1 is sodium. So this one also is soluble. Therefore, iron 2 carbonate will be insoluble, or the least soluble. Same question here, number 7. Which one is insoluble in water? We're looking at sulfates, we're looking at chromates, we're looking at chlorates, and then we have a group 1. Group 1 ions, they are always soluble, so that's not one. We're looking for something insoluble. Chlorates, right here, they're always soluble, no exceptions. So that one, and besides it also has a group 1 in it. Then we have sulfates, down here, sulfate. They are soluble except with silver. We don't have silver. Calcium, we don't have calcium. Strontium, we don't have strontium. But barium, it says barium compounds, they are insoluble. So we're looking for something that's insoluble. So there it is, right there. That one is the insoluble one. Number 2 there says chromates. You're saying, wait, but chromates are insoluble. Chromates are insoluble, but it says except with calcium. If it's with calcium, then it is soluble. So the insoluble portion, the insoluble one, is this one down here, the sulfate, barium sulfate, because barium with the sulfate, right, with the sulfate is going to be an insoluble substance, which is a homogeneous mixture. The trick is which one is a mixture. That's a solid, that's a liquid, that's a gas. There is a mixture. That says HCl and water. Both of those things, that makes it a mixture. Okay, this question here, number 9, is drawing on your knowledge from back in the last unit. We have to remember what's what. Well, likes dissolve likes, so we want to make sure that we have like things to dissolve one another. So if we're talking about likes dissolving likes, that means a polar solvent will dissolve a polar or ionic solute, whereas a nonpolar solvent will dissolve a nonpolar solute. So now we need to decide what we have here. So let's look. CCl4, that is nonpolar. Remember, it's nonpolar because it has symmetry. It's a symmetrical molecule. You need to remember that. Nonpolar, which is a nonpolar solvent. All right. Potassium chloride, however, what is potassium chloride? This is a metal. This is a nonmetal. So therefore, we have an ionic compound here. This is an ionic. So ionic will not dissolve in a nonpolar solvent. So that is not going to happen. The ionic compound, we're looking for something here. We're looking for a polar solvent. CCl4, again, even though they say it's a polar solvent, it isn't. Just saying so doesn't make it so. But water, we've learned, water is a polar solvent. So water, being the polar solvent, will dissolve the ionic substance, potassium chloride. So like I just said, number 9. And number 10, we're talking about likes dissolving likes, okay? We're talking about the fact that the student determined the solubility of unknown solids in various solvents, okay? They found that the substance, wherever it was, it did not dissolve. It was insoluble in benzene. It was insoluble in benzene, all right? And remember, if you don't know anything, nonpolar solvents dissolve nonpolar solids. Benzene, organic compound, this is nonpolar. All right, so if it's insoluble, that means it's probably a polar. It's soluble in water. It's soluble in water, which is polar. So whatever this is either got to be polar or it's ionic. So this is polar, or it's an ionic compound. All right, ethanol, slightly soluble. Okay, toluene, insoluble. Again, nonpolar. So based upon this, we're looking at either a polar or an ionic. Our choices are polar, ionic, and the one we have is ionic. And so there you go.